Looking for a simple way to add some useful functionality like authentication, compression, or rate limiting to your Kamal-deployed apps without having to modify your codebase? Keep watching to learn how. Getting your web applications deployed couldn't be easier with Kamal. Once you have your application in a Docker image, you can get your entire tech stack up and running with a single command. Kamal's deployment functionality works great, but did you know you can use Kamal to further extend the functionality of your app? Thanks to Traefik, the underlying proxy service that Kamal uses to route traffic to your application, you can set up middleware to add some helpful functionality to your web app. In Traefik, middleware acts as a bridge between requests to your server and your application running in a Docker container. It intercepts incoming requests and modifies how it handles that request, like changing the headers before passing the request to your app or redirecting the request elsewhere. With Kamal, you can set up Traefik middleware simply by adding a few labels to your web application container. That way, you can let the proxy service deal with things like basic authentication, compression, rate limiting, and more without having to add more code to your app. In this video, I'll teach you how you can set up middleware for your Kamal-deployed apps and show a few useful ones in action. Let's dive into it. For this video, I'll use a Ruby on Rails application that I have showcased on this channel many times before called Airport Gap. I have this application set up to deploy with Kamal and it's working without any issues. If you're new to Kamal and want to learn more about how to set up Kamal for your web applications, check out my channel for some recent videos that dive deeper into that topic. I have a demo of Airport Gap up and running with most of Kamal's default settings, as well as having HTTPS connectivity set up using Let's Encrypt. I also have another video talking about this topic in detail, so go check that out if you want to learn how to set up secure connectivity on your web apps when deploying with Kamal. Now that I have my demo application working, I want to extend its functionality with some of Traefik's built-in middleware. Traefik has a bunch of useful middleware that you can use for your web applications, and we can configure most, if not all of them, through our Kamal configuration. To do this, you'll need to have a Traefik router label set up for the web role in Kamal, so you can connect the middleware in between the user request and the service running your application. If you need to learn more about how to set up routing in Kamal, check out my previously mentioned video on how to set up HTTPS, where I explain how routing works and how to set a router for your app. The example application I'll use in this video already has a router set up, so I won't go through that process here. To demonstrate how to set up middleware when using Kamal to deploy your apps, I'll go through the process of setting up a few of them and show how these settings affect your web application. The first middleware I'll set up is the compress middleware. This middleware tells Traefik to compress the response from the web application service before sending it back to the browser, which will automatically handle decompressing the information for display. Traefik uses gzip compression, which is widely supported by modern web browsers. Depending on the web page, gzip compression can significantly reduce the amount of data sent back to the client and make your site respond quicker. When making a request to a website, your browser will automatically set an accept encoding request header with the values of the type of encoding or compression algorithm it could handle. The web server sees this header, and if it supports one of the specified methods, it performs the encoding process and returns the data, along with a content encoding response header so the client knows how to process it. By default, Traefik doesn't compress responses before sending them back to the client, and Kamal doesn't set up this middleware either, so the browser will receive uncompressed data for all responses. We can check this out by opening the developer tools in your preferred web browser. Here I'm using Chrome, so I'll go to the network tab and filter by doc so we can see the response headers for the web page. If I reload this page and check the response headers, we can see that there's no content encoding header despite the browser sending an accept encoding request header with the compression algorithms it supports. Let's change that by setting up the compress middleware in our application. Setting up this middleware is pretty straightforward, only requiring one label. Under the server section in our Kamal configuration, let's add a new label to the web row that we've specified here. Labels for Traefik middleware begin with traffic.http.middlewares. The next segment of the label is the name we want to call our middleware. The name can be anything you want and will serve as the identifier for hooking up the middleware to the router. For this example, I'll call the middleware airport gap compress. The segment after the middleware identifier is going to be the name of the actual middleware. In this case, the compressed middleware built into Traefik is called compress. This label accepts a Boolean value, so we'll set it to true. We've configured the label to let Traefik know we want to use the compressed middleware. Now we need to hook this up to our router. To do that, we'll add a new label for our specific router that we've already configured. For this configuration, I have a router using airport gap as its identifier. So I'll create a new label called traffic.http.routers.airportgap.middlewares. The value of this label is the identifier of our middleware that I set up just now. I'm identifying the middleware as airport gap compress, so that's the value that'll go here. That's all we need to enable and configure middleware into a Traefik router for our Kamal configuration. To activate the middleware, we'll need to redeploy our web application, which we can do with Kamal-redeploy. After the application redeploys, we can reload the page again and check out the headers. Now we can see that the server returned a content encoding header with a value of gzip, meaning that gzip compression is now working correctly, so our middleware is working as intended. However, you may have noticed that the accept encoding request header that the browser sends to our server not only has gzip encoding as a value, but it also has additional compression algorithms like Brotli, set as BR, and zstandard, set as zstd. These algorithms are newer and they work better than gzip, having a higher compression ratio. So why did Traefik compress with gzip instead of using one of these newer alternatives? The issue is that Kamal, as a version 1.8.1, uses an older version of the Traefik proxy service, which is version 2.9. The compressed middleware for this version of Traefik only supports gzip compression. Fortunately, we can also tweak Kamal to use a newer version of Traefik if we want support for these newer compression algorithms. Under the Traefik section of our Kamal configuration, which is a root level key if you don't have it set up, we can tell Kamal which Docker image to use with the image setting. The value for the setting is the name of the image that's publicly accessible on Docker Hub, which is Traefik, and the tag for the latest major version as of this recording is version 3.1. While this image is a couple of major versions ahead of the one that Kamal uses by default, there haven't really been many breaking changes as far as how Kamal sets up the proxy service. So unless you're heavily changing how Traefik works with your Kamal setup, using a newer version likely won't require any additional changes. However, always test out any changes like these on a staging environment if possible to avoid any surprises in production. I've already checked that this new version of Traefik won't affect my demo app, so I can go ahead and reboot the Traefik instance using Kamal Traefik reboot. This command shows a warning that there will be some downtime, which is fine for this example. So it'll then proceed to shut down the old Traefik service and spin up a new one using the latest Docker image. So now if we reload the page and we check the response headers once again, we'll see that the server responded with the content encoding header this time, indicating it used the zstandard compression algorithm. So with just a few minor tweaks in our Kamal configuration, we're able to improve the user experience by making our site load a bit faster compared to the default setup. The compressed middleware has additional options such as excluding specific content types from being compressed and setting the minimum number of bytes a response body must have before it qualifies for compression. These options can be added as additional labels to the application container. When setting up any Traefik middleware, make sure to read the documentation to learn how to modify it for your needs. Now that you've seen how easy it is to set up Traefik Middleware with Kamal, let's look at a few more pieces of middleware that can expand the functionality of your deployed apps. Before going any further, I'll remove the Traefik image setting that I added to the configuration and reboot the service to make sure we'll use the default version of Traefik provided by Kamal using forward for this example. The next middleware we'll check is the BasicAuth middleware. The purpose of this middleware is to set up HTTP basic authentication when a request comes in through the Traefik router and only allows access to known users with a predefined username and password. This middleware is useful if you want to add a quick and simple way to restrict access on a particular page or section of your site to a handful of people. For this example, let's imagine the demo site I set up has some new functionality that I don't want to expose publicly on the internet. So I'll set up the BasicAuth middleware to password protect the site. Going back to the server section of my Kamal configuration, I'll comment out the label for the compressed middleware for now, and I'll add a new middleware label starting with traffic.http.middlewares as mentioned earlier. I'll identify this middleware as airport gap auth, which is the next segment. Then the name of the middleware is BasicAuth. The middleware needs to be followed up with a users option. The value for this label is a string consisting of a username and the hash password. To generate the hash password, we can use the htpassword command line utility, which is available on most Linux distributions as well as on Mac systems. The htpassword command by default requires a file name to store the contents of the hash password and a username to use for the authentication. We only want the contents of the hash password without creating the file. To do that, we'll add the end flag, which will output the contents without requiring us to specify the file. Additionally, the htpassword command hashes the password with the MD5 based hashing algorithm by default. While this should be okay, we can make our password hash a bit more secure by specifying the B flag, which hashes the password using bcrypt, which is a more secure hashing function. I'll use airport gap as the username for authentication and hit enter. The utility will prompt me for the password I want to use. And after confirming it, it'll show our username and hash password combo. This string is the value we'll set up for the BasicAuth middleware label. So I'll copy it here and I'll paste it as the value of this label. So this sets up one username and password combination for our BasicAuth. If you want to set up more than one username and password for basic authentication, you can include multiple users and hash passwords by separating them with a comma, like this, for example. You can also use the users file option instead of users, which allows you to set a list of usernames and hash passwords in a file that Traefik can use for authentication. We'll keep it simple for this example, so I'll just set up a single user for authentication. The only thing left to do is to hook this middleware into the router, so I'll update the label of the middlewares for the router and set up the new one, which should be airport gap auth. Once I save the file, I'll redeploy the application to activate the middleware. So now when I visit the demo site after the application is redeployed, it'll prompt me to enter a username and password before I'm able to proceed. Entering the username and password that I set up using the htpassword command line utility will let me access the site. Using the BasicAuth middleware is really useful since you don't have to modify your application if all you want is a simple way to restrict access on a site to a handful of trusted users without anything fancy like two-factor authentication or email confirmations. Let's move on to another piece of useful middleware, which is the ReplaceRegex middleware. This middleware can match a segment of the request URL using regular expressions and redirect that request to another page or another URL altogether. Let's say I'm finished using my demo site, which is under the demo.airportgap.com domain, and I want to redirect anyone who goes to any page on the demo site to the main site, which is airportgap.com. I can use the ReplaceRegex middleware to handle it for me. I'll comment out the label I use for the BasicAuth middleware and set up a new middleware label starting with Traefik.http.middlewares, as we've done already. And I'll call this middleware airport gap redirect. And the name of this middleware is ReplaceRegex in a single word. Now, the ReplaceRegex middleware needs two labels to work correctly. The first label we'll use is the regex option, which is a string containing the regular expression we want to match on the request URL. We can also use this option to capture any segments to pass it along with the redirect, which I'll show in a moment. I want to redirect any requests made to the demo.airportgap.com domain, so I'll start this regular expression with a caret to indicate that we want to begin matching from the start of the request URL. I want to match the URL scheme, so just to make sure it captures both HTTP and HTTPS, I'll add a question mark at the end so it matches whether the S is present or not. The next segment to match is the domain itself, starting with the : the domain name, which is demo.airportgap.com, and including the trailing slash at the end. Finally, I want to capture everything after the root domain so I can include it as part of the redirect URL. We can do this with a capture group, opening parentheses, and telling it to match everything inside with a period and an asterisk, which means match every character that's in between these parentheses. One thing to note here is that when setting up this label using Traefik and Kamal, we don't need to escape characters like the / or periods like you might need to do in programming languages, so we can just match them directly as it is here. This option takes care of the matching segment. Now we need a label to know where to redirect the request. The label starts the same as before, Traefik.http.middlewares, the identifier, which is airport gap redirect, and the name of the middleware, which is ReplaceRegex. The next option we'll use is the replacement option. The value of this label will let Traefik modify the request URL based on the match done on the regex option and perform the redirect. As I mentioned, I want to redirect all requests from the demo site to the main airportgap.com domain. So the value I'll set here is https airportgap.com. I also want to include the additional portion captured by the regex option, which I can do with a $1, meaning to use the value of the first capture group from the previous regular expression. Once these two labels are set, I'll hook this middleware up by setting the value of the router's middleware to my identifier. I'll save these changes and redeploy my app to activate the middleware. Now, if I try to go to demo.airportgap.com, I'll instantly get redirected to airportgap.com. If I also attempt to go to demo.airportgap.com/login, for example, I'll get redirected to the main airportgap.com domain with everything that was captured after the root domain. So it looks like the middleware is working as expected. The ReplaceRegex middleware is really useful when you need to redirect to different domains or slightly tweak your existing one, like redirecting from a www to a non-www to make one of them the canonical URL for your site. Traefik has other middleware for modifying the request URL for different purposes, like the add prefix middleware that updates the path of the URL before forwarding it to the application container, and the ReplacePathRegex middleware that works very similar to the RedirectRegex we just showed, but it focuses on the request path and doesn't modify the root URL. As always, read the Traefik middleware documentation to learn more and figure out which middleware would work best for your scenario. Finally, the last middleware I'll demonstrate in this video is the RateLimit middleware. This middleware allows you to manage the number of requests you want a service to handle. It uses the token bucket algorithm, which allows a certain number of requests or tokens to be made in a given period with an optional burst. Tokens refill over time, and requests can only be processed if there are enough tokens in the bucket available for that period. This middleware lets you define what to consider as the source of a request, like by IP address or request headers. You can use these settings to create separate rate limiting buckets for different sources or routes, but for simplicity, I'll use the default criterion, which only checks the IP address that traffic receives. As I did before, I'll comment out the existing labels for the ReplaceRegex middleware to set up a new label for this middleware. Starting with the usual traffic.http.middlewares segment with the identifier of airport gap rate limit, and follow it up with the name of the actual middleware, which is RateLimit. The RateLimit middleware uses a few options to determine how to limit incoming requests. The first one is the average option, which is the average number of requests allowed in a given period. If this option isn't specified, Traefik will set this to 0, which means that there's no rate limiting for this router. So let's say we want an average of 10 requests for each period that we specify in this middleware. To specify the time period, we'll add another label for this middleware, starting with traffic, HTTP middlewares, the identifier, the name of the middleware, and the option of period. This option sets the time window for calculating the maximum number of requests based on the average. The default period, if not set, is 1 second. So right now, without this label, we're setting up our middleware to tell Traefik to allow 10 requests per second. So if I set this label instead to 10s, which is a duration string indicating 10 seconds, that means Traefik will allow 10 requests every 10 seconds, or 1 request per second on average. To demonstrate how rate limiting works, I'll set an average of 10 requests and set the period to something like 5 minutes, which I can do with this 5m string. These settings aren't something you'll likely do in a production environment, since this sets a really super low rate of 1 request every 30 seconds, but this is just to see how rate limiting works with real requests for this example. I'll also hook up the middleware to the router by setting the middleware's label to my identifier, which is RateLimit. After saving these changes, I'll redeploy the app. Now that the application is rate limited, I'll make a request to the Airport Gap API from the terminal using curl. I'll use the I flag to get the response headers and make a request to an API endpoint. So let's use demo.airportgap.com/API/airports/KIX, which is my local airport. And this should fetch the data of that specific airport from the application database. So this first request works as expected, returning a 200 response and the JSON I requested. Now, if I make that same request again, the API returns a 429 too many requests response, meaning that I've hit the rate limit from Traefik. Traefik also returns different response headers to let us know when we can retry the request again. The retry after header contains an integer of the number of seconds until we can make our next request. And the xretry in header returns a more precise string of the same information, which the client can use to calculate when to make a follow-up request. If I let these seconds pass and make the same API request again, we're no longer rate limited and we'll get our expected response. So we'll see our rate limiting is set up to handle a steady flow of traffic. So what if we need to be a little more flexible with the number of requests we get? In a real-world scenario, our web applications don't receive a constant amount of traffic. We can receive a sudden influx of requests during peak times, and our rate limiting might be a little too aggressive. We can be a little more flexible by setting a burst to our rate limit. A burst lets us define how many additional requests we can allow in a specified period before the rate limit kicks in. This setting helps handle a sudden rush of traffic that we know our server can process, but don't want to rate limit immediately. To show how it works with Traefik Middleware, I'll create a new label. Once again, starting with Traefik, HTTP, middlewares, airport gap, rate limit, which is our identifier. Then the name of the middleware, which is rate limit, and an option called burst. The value of burst is the number of additional requests we'll allow for each period before getting rate limited. So for this example, I'll just set it to 3. So this means that during the 5-minute rate limit period that we specified for this middleware, Traefik is going to allow at a maximum 3 requests instead of calculating the average. So you might be asking, why set a burst instead of changing the average or the period in the rate limit configuration instead? So the main difference between setting a burst and modifying one of the other values is that the number of burst requests doesn't factor into the calculated rate of requests per second, and these burst requests only happen once during the specified period. So for this example, we only have 3 burst requests for this 5-minute period that we set. Once we run out of burst requests, we'll hit the regular rate limit of 1 request every 30 seconds on average as before. The burst requests will then refresh again after 5 minutes. So despite having a few additional requests in our rate limit period, the calculated rate allowed by Traefik, according to the average and the period, is still going to be based on the average and the period settings. So despite having a few additional requests in our rate limit period, the calculated rate allowed by Traefik is still going to be based on the average and period settings that we set for the middleware. Depending on your needs, this may or may not be what you want, so for a production environment, you'll have to play around with these numbers to find what's right for you. To better understand this, let's see how the burst works. I'll save this new label and redeploy the app. Once that's finished, I'll make the same request to the API as before. The first request goes through as expected. If I immediately make another request, we'll see that it also goes through instead of getting rate limited as before. A third request will also go through without any issues. However, on the 4th request, we'll hit our rate limit because we've gone past what we define as our burst. If we notice the response headers, we'll see the retry time is similar to what we had before. Once I can make requests again, we can see that the first one will work, but the second one is going to be rate limited as before. That's because we ran out of burst requests for the 5-minute period. I'll have those 3 burst requests back in my bucket after 5 minutes. Hopefully these examples show how rate limiting works in Traefik. The middleware documentation has a lot of additional settings to modify, so make sure to check those out before implementing them for your Kamal deployments. We've seen a few useful pieces of middleware provided by Traefik and how they work individually. But we can also combine more than one middleware in a single router. So let's say that I want to keep the rate limit middleware here, but let me use some sane values like 5 requests every second with no bursting. And I also want to enable the compression middleware again, along with setting up basic authentication as I had before. To hook up more than one piece of middleware to a router, all we need to do is to add the identifiers to the router's middleware label separated by commas. So for this example, we already have the rate limit middleware activated for this router. And then we'll also add the airport gap compress middleware that I identified before, along with the airport gap auth middleware that handles the basic authentication. So with this configuration, I'll have all 3 middlewares active for my router. When I redeploy my app with Kamal, all 3 of these pieces of middleware will now be active. If I go to the demo site again, I'll be hit with the basic authentication prompt again. And once I go through the site, if I check the response headers again, I can see that I have the content encoding header set with the gzip compression because I reverted back to the older version of Traefik. So it means that these middleware are all working together, along with the rate limiting, which is happening under the hood. So if I were to hit the API 5 consecutive times in a row, I would probably be rate limited. This video shows how Traefik's middleware can add useful functionality to your deployed web applications with very minimal configuration. With just a few labels, you can handle a few necessities like improving performance through compression and keeping your app running smoothly with easy rate limiting, all at the deployment level. The cool thing is that the middleware I showed in this video is just the tip of the iceberg. Traefik has many more middleware you can add to your Kamal-deployed apps, and you can mix and match them using different routers to create some really powerful deployment strategies for your needs. So make sure to experiment with them to see what works best for you. As always, if you found this video helpful, consider subscribing to this channel for more tips on helping developers ship their code confidently, from development to deployment. You can also check my website for more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. And if you or your team are looking for an experienced software engineer to help with Kamal or give a boost to some of your challenging projects, feel free to reach out. Thanks for watching, and I'll see you in the next video.